Hello and welcome to this video about solving radical equations, part 2. The learning target for this video and lesson is to use factoring to solve radical equations. So let's talk about the difference between part 1 and part 2. In part 1, all of the equations we were dealing with were something like the square root of x plus 3 is equal to 10, the square root of x minus 7 plus 4 is equal to 14, something like that, where we only had one variable and it was underneath a radical. What we're going to see now in part 2 is square root of x plus 3 is equal to x, where we're going to have a variable under the radical and we're going to have a variable without the radical. And now, because of that, when we square both sides, something different is going to happen. And that's why we separate this between part 1 and part 2, because the process differs. So let's first of all talk about some vocab. What's going to happen is we're going to run into some extra answers. And the fancy phrase for that is extraneous solutions. And what these are, they are solutions that you're going to get, but don't work when you put them in the original equation. So don't work in the original equation. All right, so when you go to solve, you have to check both of your answers to make sure that they work. And what we want to look out for is we do not want the square root of something equal to a negative number. So if we have this situation right here where a square root equals a negative number, that solution is considered an extraneous solution. And so we'll go over what that looks like with an actual example in a few minutes. But that's sort of what we're looking for. If we have the square root set equal to a negative number, we have an extraneous solution. Now, let's briefly talk about why. How does this work? Graphically speaking, I think is the best way to kind of go about it. So you'll notice the blue line is the graph of the square root of x plus 6. The red line is the graph of y equals x. And so if we were to solve this, the equation we would have square root of x plus 6 is equal to x. And so this is a way to kind of solve it graphically to find out that the answer, or the x value of this, is going to be 3. Now, when you do the actual work, you're going to get two answers. You're going to get x equals 3 and x equals negative 2. The thing is, x equals negative 2 is going to be considered an extraneous solution that you're going to have to eliminate. And if we take a look at it graphically, you can kind of see what's going on. The graph of the square root of x is actually a sideways parabola. But sideways parabolas aren't considered to be functions. And so what I've done is I've filled it out. Now, normally you don't have it filled out because that would make it not a function. And you can see that it should intersect right here at negative 2 using the axis of symmetry here. But the graph clearly shows that's not happening. So mathematically, you'll get the number x equals negative 2, but in reality, there's nothing there. So that's why that's considered an extraneous solution. All right, so we have to double check. Now, let's talk about the process. It's a little complicated, but I've narrowed it down to about 5 words, give or take. First one, just the same as part 1. You have to isolate the radical. Get that by itself. Then you will square both sides. After that, you have to set equal to 0, because odds are you're going to have especially if you have two variables, one under a radical, one not under a radical, you're going to have an x squared situation. So we need to get this ready to factor. And so that would be step 4, which is factor and solve. And then step 5 is to check. Sometimes you might have 2 answers, other times you're only going to have 1. So now, enough talking. Let's actually take a look at some examples here. So the first example I have, square root of x plus 5 is equal to x plus 3. All right, so this one's eliminating that whole isolate the radical. Because our radical is already isolated, we're good to go. So we jump into step 2, which is squaring both sides. Now, when we square the left-hand side, we're going to be left with just x plus 5 because the square and the square root cancel each other out. On the right-hand side, we have to keep in mind this is x plus 3 times x plus 3. So we actually have to FOIL that out to get x squared plus 6x plus 9. Now we're at step 3, set equal to 0. So I need to move everything over to one side of the equation. So I'm going to subtract x, I'm going to subtract 5, and so I'll have 0 equals x squared plus 5x plus 4. Now I have a trinomial and I can go to step 4, which is to factor and solve. 0 equals x, and then looking at 4, the factors of 4 that can add up to get 5, 4, 1 plus 4. And so continuing on, that means that, and I break these up into two little equations. So x plus 4 equals 0, x plus 1 equals 0, x equals negative 4, or x equals negative 1. Now we have to double check. We have to go back to our original equation, and I'll just write it down right here so we can check it. Square root of x plus 5 is equal to x plus 3. If we put in negative 4, so x equals negative 4, we'll have negative 4 plus 5 is equal to negative 4 plus 3. Square root of 1 equaling negative 1. This is what I'm talking about. We have a square root equal to a negative number. That's no good. We don't want that. So that means that x equals negative 4 is an extraneous solution. We try x equals negative 1. Negative 1 plus 5 is equal to negative 1 plus 3. Square root of 4 is equal to 2, which is a true statement, so this is good. And this is our only actual solution. We'll do another one. Okay, so this one, we're going to make it a little more complicated. So our second example, we have 3 plus the square root of x minus 1 is equal to x. All right, so first I need to isolate the radical. I need to move my 3 over to the other side. So I got to bump this guy over. When I do that, I'm left with the square root of x minus 1 is equal to x minus 3. Next step, square both sides. Keep in mind these undo each other, so x minus 1 is now equal to, and then this is x minus 3 times x minus 3, which is x squared minus 6x plus 9. I can get rid of that so I can do some more work there later. All right, good. Now I need to set everything equal to 0. So I'll subtract x, I'll add 1, subtract x, add 1. And so I have 0 equals x squared minus 7x plus 10. Now I'm at factor and solve. So let's see, our factors of 10, that can get me 7, are 5 and 2. They have to have the same sign and both be negative. So I now end up getting, what do I get? X equals 5 and x equals 2. But before I box them and walk away, I have to check to make sure that I don't have an extraneous solution. And maybe to make things a little bit easier, use this part right here. So we're going to check x, the square root of x minus 1 is equal to x minus 3. Because really what we care about is, do we have the square root set equal to a negative number? So that's why, I mean, if I wanted to, I could use this one up here, but it might make things a little more confusing. All I really care about is, do I have a square root set equal to a negative number? So I'll put in 5. X equals 5. I will get 5 minus 1 is equal to 5 minus 3. Square root of 4 equal to 2. That works out. Everyone's happy. So we can definitely box that one. Let x equal 2. We'll have 2 minus 1 is equal to 2 minus 3. think we saw this variation earlier where you'll have the square root of 1 is equal to -1. That's not good. We don't want that because we have the square root set equal to a negative number. So that's an extraneous solution. It's not a real solution. So just to recap, I'm going to show you those 5 steps. It starts off with isolating the radical, squaring both sides. Keep in mind that squaring both sides is going to lead to foiling on one side. Set equal to 0, so that way you can factor and solve, and then you have to check. And the big thing you're looking for is a square root set equal to a negative number. If you have that, it's considered an extraneous solution, and you just use the other one. Let me know if you have any questions, and good luck with your homework.